So this is your homework problem. I did kind of misspeak a little bit. I said between subjects designs, participants were randomly assigned to conditions. That's not always true. Sometimes you have quasi-experimental designs, like the design today. You would still use an ANOVA on this problem. So the design is simple: class and school, first year, sophomores, juniors, seniors, super seniors, and their maturity level has rated by their advisors. The null hypothesis is that there is no difference in maturity across different classes, and your job is to do all 5 steps. So go ahead and pause this video and give that a shot. I will give you the answers shortly. So how do you solve this problem? Well, the first thing you have to do is put your data into Jamovi. I've just entered my data into Jamovi. Double click, participant ID. That is an ID variable. This right here is college class. That is a nominal variable. And this right here is maturity. That is a continuous variable. Let me make this big so we can see. Now, first thing I want to do, explore descriptives. Split by college class, maturity in the variables, statistics, mean and standard deviation. Just looking at this, it's kind of hard to tell what's going on, if anything's going on. We don't know, but we at least have all the means and standard deviations here in our data. The next thing I would like to do is go ahead and analyze my ANOVA. Analyze ANOVA, not repeated measures, just regular ANOVA, with my dependent variable being maturity, my fixed being college class, my partial eta squared being rather large. This is one of those cases where not everything's great, but that's okay. We can see right here that the p-value is 0.226. So if the null hypothesis were true and all 5 of these population means were the same, you would get data as similar to our data 23% of the time. 40% of the variation in the data is driven by our independent variable. That is a large effect, but because the p-value is so high, it doesn't really matter. We don't know it. We can't reject the null. We can't retain the null. We know nothing, okay? So we still know nothing just because we found a large effect. It suggests that we ran a really bad study. That's essentially what's going on here. Outside of that, we want to look at we still definitely want to make the graph just to see if anything's worth exploring. If anything, we kind of see an interesting relationship where it looks like maturity does increase over time unless you're a super senior. But ultimately, that's just a pattern of data that we're seeing. I needed to change those to standard error. That's just a pattern of data that we're seeing. But ultimately, we are not finding any significance. There is no difference among these means. I am going to select all on copy. Here we go. I plotted what I know. All right, so now that we've run it, let's see how we would like the answer put in there. I would like to see your descriptives, means, and standard deviations in there in the table. I would like to see your ANOVA output. In this case, we have a non-significant but large effect. I'll show you how to talk about that in a second. Additionally, we have our graph that looks like, according to advisors, that the super seniors and the first years are viewed as a little bit less mature than anybody else. But remember, none of this was significantly different from each other. So step 4, interpret your results. Our p-value is greater than 0.05, thus I literally know nothing. It was a large difference. But when I put those together, I still know nothing, right? When my p-value is greater than 0.05, it's very likely that I ran a study with a lot of error, and thus any statistics I get from it are just unusable. So I do have a large non-significant difference here. That's kind of how I write it, because it is a large difference among the means. I don't know where, but still. But nonetheless, it's a non-significant difference. So I literally know nothing. I'm not saying, oh, I have a large effect, I know something. No, I'm saying because my p-value is greater than 0.05, I know nothing. Yes, I do have a large difference. I want you to write that down. But in this case, the p-value trumps the effect size. And then you just write your statistical sentence. I literally copied my last one and changed it up for this problem. I changed a few words here or there. Um, it doesn't really matter. Clearly, the red stuff is just there. You need to describe the test you ran. You need to describe your independent variable. You need to describe your dependent variable. You need to point out your effect size and your p-value interpretation.